Probability IB questions number 4. This question does not ask you to draw any sort of a diagram. I chose to draw a tree diagram because it helps me to make a little bit more sense of what's going on. So I drew that over here. I chose to put Jockey first and Eric second. I didn't necessarily have to do that. I could have chose to put Eric first and Jockey second. As you can see, when we're multiplying across to find the probabilities of, let's say, 2 hits, we multiply 0.65 by 0.5. If we look at the tree diagram down here where Eric's first, instead of having 0.65 times 0.5, we have 0.5 times 0.65, but what do we know about multiplication? That's okay, it's going to give us the same thing. So I'm going to delete that because we're not focusing on that tree diagram. I decided to draw it with Jockey first. In order to use these tree diagrams, again, I went into more depth in problem number 1, but we multiply across the branches, and then if we have 2 instances that are the same, we add those probabilities together. We'll talk about that a little more when we go down to part C. But for part A, they ask us to find the probability of both players hitting the bullseye. That means that Jockey hits, right here, and that Eric hits. So, probably saying to yourself, all right, what am I doing in this case? I'm multiplying across the branches. So I say the probability of 2 hits, of Jockey hitting and Eric hitting, is equal to 65 hundredths times 5 tenths, so 0.65 times 0.5. And that's going to give us 325 thousandths. Or we can put it into percents and say that this is 32.5%. It's up to you again. You can put your probabilities as fractions, as a decimal, or as a percent. Just remember that probabilities are between 0 and between 1. So we have probabilities, their numbers are always between 0 and 1. So if you have anything above 100% or above 1, you should probably look at your work. Let's look at part B. It says, find the probability of both players missing the bullseye. Well, that's 2 misses. We look at Jockey missing, we look at Eric missing, we multiply across the branches. We know this probability is going to be 35 hundredths times 5 tenths. So that gives us 0.35 times 0.5, which gives us 175 thousandths, 0.175. Now let's take a look at C. Here, we're trying to find the probability of either one of them, but not both, hitting the bullseye. If we look at our end products, we know that 2, purple ones that are circled, these 2 events fulfill one of them hitting, but not both hitting. So here, we have Jockey hitting and Eric missing. And here, we have Jockey missing and Eric hitting. So we say the probability of a hit and a miss, multiply those down the branches, we find our probability, the probability of a miss and a hit, multiply again down the branches. Then what do? Well, we have 2 events that fulfill what we're looking for, so we add them together. So as you can see, we'll color code this so it makes it a little easier. The probability of hitting and missing is this. The probability of missing and hitting is this. We add those 2 events together because we can either get a hit and a miss or a miss and a hit, which gives us 1/2, essentially. So 50%.